Hi guys, this is Proof Architect here to show a very concise demonstration that if you were to get any complex number and multiply it by its identity element, which is essentially the imaginary number I, you will get a rotation of that complex number in all four quadrants of the Argand diagram. So I've written my four complex numbers here: a plus bi, minus a plus bi, minus a minus bi, and a minus bi. And the reason why these are correct representations of complex numbers in these four quadrants is because due to the signs of their real and imaginary components. For z1, the sign of the real part A is positive, imaginary part is positive 2. For z2, real is negative, imaginary is positive. For z3, real is negative, imaginary is negative. And for fourth quadrant, real and imaginary are, real is positive, imaginary is negative. So then what I want to do is multiply these by I, and then show that I basically get these other guys under rotation once I do it. So let's do this out. So z1 times I, that's just a plus bi times I, and we get ai plus bi squared. But remembering that I squared equals -1, that just simply becomes a real part now. Negative b plus ai. So not exactly the same, but we essentially get some integer plus another integer, which is imaginary now. Now let me do it with z2. z2 times I. Negative a plus bi times I get negative ai plus bi squared. So I get negative b minus ai. And here we're good as well, because now both real and imaginary parts are negative, so we belong in the third quadrant now. Let's do it z3 with I, minus a minus bi times I. So I get a negative ai and a minus bi squared, and the I squared becomes -1, so I just get positive b minus ai. Good, real part is positive, imaginary part is negative, so it belongs in fourth quadrant. Finally z4 times I. A minus bi times I get ai minus bi squared. So that just becomes, see, I squared is -1, so I just get b plus ai. Boom, right back where we started. First quadrant, cyclic group of order 4, baby. And yep, that's all it's done. And above here is set theory notation of how you represent the complex numbers. Out of curiosity, z is an element of the complex numbers where z equals a plus bi, given that a and b are elements of the real numbers. So that's it, done. Hope you have a nice day and stay safe out there during the pandemic.